Hello, I'm Dan Alford. Welcome to the ARC Specialties Weld of the Week. This week's Weld of the Week is inspired by you guys. We noticed that you seem to enjoy some of the older technologies, and I applaud you for this. This is how we build things at ARC Specialties. We take some of the old technology, apply new technology, and do great things. It makes us look smart, but we're actually just reapplying old solutions to new problems. So this technique today is called sweat-on, and I suspect there'll be very few people in the audience that are aware of it. I was a technician at the Hughes Tool rock bit plant in the late 70s, and this was a technique that was being phased out at that time. But it's kind of interesting because it allows you to apply a hard face coating on a part without dramatically increasing its thickness. Another thing we've noticed from our comments on our other videos is people are applauding our PPE, our safety techniques. I'm a huge fan of that. I believe everybody ought to go home with the same number of fingers and eyeballs they come to work with. So we're going to use our PPE today. I'm including earplugs and gloves. First step in this operation is we grind the part down to clean metal. The second step is we're applying something called sodium silicate or water glass. This is a high temperature adhesive which is used as a binder in electrode manufacturing. So we simply paint it onto the part in the exact pattern that we want to have the carbide adhere to. So once you have the pattern that you like, then you simply add the carbide. In this case we're running cemented tungsten carbide to the part, and it adheres every place we have the water glass or sodium silicate. And at this point, we simply allow the water glass to dry. So we're back, the sodium silicate's dried, the tungsten carbide's adhering to the plate. What we do now is remove all the excess carbide with a brush, leaving just the pattern that we painted on with the sodium silicate. Next step is we have to fuse this into the base metal. The point of this exercise is we're trying to use the base metal as the matrix and the carbide as the wear-resistant material. The welding process we're using this week is atomic hydrogen welding. If you'd like more information on the process, go back to episode 5 of Weld of the Week while we cover it in detail. There's other ways you could fuse this carbide into the base metal. You could do it with oxyacetylene, you could do it with plasma, and possibly even with TIG welding. But we wanted to show you how this was done in the old days, so we're using the old technology. So what we've accomplished is we've actually applied tungsten carbide to the work surface without any matrix. We're using the base metal as the matrix itself. So it's an inexpensive way to do this. It also does a minimal addition of thickness, so you don't have to pre-machine the part down thinner before you do it. Is there an application for this in the current world? Possibly. If you find one, call me, we'll talk. We're going to finish up today's episode with a modern day version of sweat-on. What we're trying to accomplish is a hard layer on the surface of titanium. We're looking to add boron to the surface. The way we did this was we mixed the sodium silicate with a boron containing material, allowed it to adhere to the titanium plate, and then we fused it in place with a plasma torch. I believe we've achieved some good results. We've doubled the hardness of the material. We're going into the lab, and we will report our results in the future episode. We look forward to posting new episodes of the ARC Specialties Weld of the Week. If you're one of the thousands of operators of ARC Specialties equipment around the world and you have a weld that you would like to showcase, please contact us. At ARC Specialties, we thrive on problems. Send us yours.